Good morning. The topic that I'm going to discuss today is the break-even point analysis. The common point between the total revenue and the total cost is called the break-even point. At this point, the total revenue equals to the total cost. Here, the company has no profit but has no loss. Since profit is equal to TR minus TC. Next, the total revenue, the total cost, and the profit functions. The total revenue is obtained by finding the product of the selling price per unit by the number of units sold. The total cost is obtained by finding the sum of the fixed cost and the variable cost. Fixed cost is constant, while the variable cost represents the cost of production per unit. The following formulas should be remembered. TR is equal to the selling price per unit multiplied or times the number of units sold. TC, or the total cost, is equal to the fixed cost plus the variable cost, where the variable cost is the cost per unit times the number of units produced. Then profit is equal to TR minus TC. At break-even points, TR is equal to TC, or TR minus TC, which is 0, or profit is equal to 0. Example. For break-even analysis, linear function. A firm sells its product at 6 pesos per unit. The product has a variable cost of 3 pesos per unit, and the company's fixed cost is 9,000. Determine each of the following. We have TR, TC, and profit functions. The sales volume and profit is 9,000. Profit when sales are 600 units. Okay, so let X be the number of units to sell. So our selling price is equal to 6 pesos per unit. Our variable cost is equal to 3 pesos per unit. Our fixed cost is equal to 9,000. For the TR is equal to the selling price multiplied by the number of units sold. So we have here the selling price is 6 times X, the number of units sold or number of units to sell. Then TC is equal to the fixed cost plus the variable cost. Our fixed cost is 9,000 plus our variable cost per unit, that is 3x. Okay? Then for our profit, that is equal to TR minus TC. Our TR is 6x minus TC 9,000 plus 3x, which is equal to 3x minus 9,000. Okay? So TR is equal to 6x, TC is equal to 9,000 plus 3x, and P is equal to 3x minus 9,000. Okay. Next, sales volume when profit is 9,000. Okay. So what is our sales volume when profit is 9,000? So if P is equal to 9,000, we have in P is equal to 3x minus 9,000, we have what is our X, that is our sales volume. Okay, X is equal to what? We have 6,000. Okay, because this will be 9,000 is equal to 3x minus 9,000. That will be X is equal to 18,000 divided by 3, that is 6,000. Okay, next, profit when sales are 600 units. Okay, so we have here again our profit function. P is equal to 3x minus 9,000. Okay, so we have there P is equal to 3 times 600 minus 9,000. P is equal to, we have negative 7,200. So since this is negative, it means that this is what? Loss. Okay? Next, the break-even quantity and revenue. Okay, so we know that at break-even, TR is equal to TC. So TR is equal to 6x equals, we have our TC is 9,000 plus 3x. So our x is equal to what? We have 3,000. Okay? Next is the revenue. This is our quantity. What about the revenue? We have, again, TR is equal to 6x. We have 6 times 3,000. And that is equal to 18,000. Okay? So this is our BEP revenue. Okay? Next, the amount by which the variable cost per unit has to be decreased or increased for the firm to break even at 2,000 units. Okay? Assume that the selling price and fixed costs remain constant. Okay, so here we have our new variable cost per unit. So let's say, let Y be our new variable cost. Okay, so here we have VC is equal to what? We have the number of units is 2,000. So that's 2,000 Y. Okay? So our total cost now is equal to 9,000 plus 2,000 Y. Okay? So for the BEP at BEP, okay, TR is equal to TC. Okay? So we have here 6 times the quantity, 2,000 is equal to 9,000 plus 2,000 Y. Okay, so what is our Y? We have there 150. Okay, so this is our new variable cost per unit. So from 3 pesos, before it's 3 pesos, it decreased to 150. Okay? Next, the new selling price per unit in order to break even at 300 units, assuming that the fixed cost and variable cost remain constant. Okay, so now we have a new selling price. So let's say let Y be our new selling price. Okay, so here we have the number of units is 300. Okay, so at TR at break even, TR is equal to TC. So for our TR, we don't know our selling price, so that will be Y multiplied by 300. Okay, that is equal to our TC, 9,000 plus 3 times 300. Okay, then our Y, our selling price or new selling price is equal to 33 pesos. Okay, so this is our new selling price. So from 6 pesos per unit, it increased to 33 pesos. Okay? Next, the number of units to sell to cover the fixed cost. Okay, so we have there TR is equal to FC. Okay, so we have here 6x is equal to 9,000. So x is equal to what? 1,500. So we need 1,500 units, okay, to sell to cover the fixed cost. Okay? Next, another example. We have here a manufacturer sells his product at 10 pesos per unit. Okay? So let us find the total revenue if the volume of sales is 1,800. Okay, so here we have the selling price is 10 pesos per unit. Okay, the sales volume is 1,800. TR is equal to, we all know that TR is equal to the selling price times the number of units to sell. We have there, the selling price is 10 times the volume or sales volume is 1,800. So TR is equal to 18,000. Okay? Next, if fixed cost is 3,000, represent the total cost when the variable cost per unit is 5. Okay? So we have here, we just need to represent the total cost. So we have TC is equal to 3,000 plus what is our variable cost per unit? 5x. Okay? Next, suppose that the variable cost per unit is 70% of the selling price. Represent the total cost when fixed cost is 5,000. So, 70% of the selling price, that's 10, is what? 7 pesos. Okay? So, we have here, our total cost is equal to, our fixed cost is 5,000 plus 7x. Okay? 7 is 70% of the selling price, which is 7 pesos. Okay? Which is 10 pesos. The selling price is 10 pesos. 70% of that is 7 pesos. Okay? Next, if the variable cost is 20% of the selling price, the fixed cost is 1,000. Find the break-even point. Okay? So we have here, TR is equal to TC. Okay? So we have, what is our TR? 10x, okay, is equal to our TC is, what is our fixed cost? 1,000 plus 20% of 10 is 2. So that will be 2x. So what is our x? We have 125. Okay? So this is our BEP or break-even point quantity. Okay? Next, what about nonlinear? Okay, so here, to increase or maximize the profit, it is a common belief that an increase in production would increase the profit. This is, however, not true in general, for as the market becomes saturated with the product, we cannot expect to continue selling it at its original price. Okay, so the price should be decreased, therefore, and the decrease sometimes depends on the number of units to purchase by the customer. Okay, so let us try this example. Okay, a product sells at 12 pesos per unit. Fixed cost is 40 pesos and the variable cost per unit is 7 pesos. After observing that the sale of the product has begun to decline, its per unit selling price is decreased by 10% of the units sold. Variable cost and fixed cost remain unchanged. Represent the new selling price per unit. Okay? So what is our original selling price? That is 12 per unit. The fixed cost is 40 pesos and the variable cost is 7 pesos. Okay? So here, the selling price decreased by 10% of the unit sold. So what will be our new selling price? So from the original 12 pesos per unit, it decreased by 10% of the unit sold. So this is our new selling price. Okay. So that's 12 minus 0.1 x. Okay. So that's per unit. So write the TR, TC, and the profit function. Okay. So the TR is equal to the selling price. That's 12 minus 0.1 x times the number of units to sell. We have there or sold. We have 12 minus 0.1 x times x, which is 12x minus 0.1 x squared. Okay. Then what about the TC? We have our fixed cost is 40 pesos plus the variable cost of 7x. Okay. Then what about the profit function? So profit is equal to TR minus TC, which is equal to TR is 12x minus 0.1 x squared minus the total cost of 40 plus 7x. Okay, so let us simplify. We have here P is equal to negative 0.1 x squared plus 5x minus 40. So this is our profit function. This is our total cost and this is our TR. Okay, next, find the break-even point quantity and revenue. Okay, so we can just use the calculator to find our two x values. Okay, so we have here, we need to equate this by this to 0. Okay, so this is now a quadratic equation. Okay, so we have our x is equal to, x1 is equal to 10, and x2 is equal to 40, or for x1 is 40 and x2 is 10. Okay, and then for our TR, okay, so we just need to substitute our x value for TR1, that is equal to, okay, 12 times 10 minus 0.1 times 10 squared. TR1 is equal to 110, and TR2, okay, we just need to substitute our x by 40. Our TR2 is equal to 320. Okay? Next, find the profit at a sale of 50 units. Okay, so we just need to substitute 50 in our equation. Okay, P is equal to negative 0.1 times 50 squared plus 5 times 50 minus 40. Okay, so P is equal to negative 40. So this is loss. Okay? Next is finding the critical points of nonlinear function. Okay, so again, as a review, we all know that there are two critical points. We have the maxima and minima. Okay, maxima or the maximum point, and minima or the minimum point. Okay, so how are we going to do that? The steps in locating the critical points, first is to find the derivative of the function. Okay, then set the first derivative to 0 and then solve for x. And then substitute this value of x in the original function and solve for y. These values of x and y are the coordinates in the maxima and minima. Okay, so to test the point, whether the point is maxima or minima, by finding the second derivative. Okay, if the second derivative is negative, then the point is maxima. If the second derivative is positive, then the point is minima. Okay, so let us try this one. Okay, locate and classify this equation. We have y is equal to negative 4x squared plus 4x minus 10. Okay, so let's find first the first derivative. So we have there y prime is equal to, we have, what is the first derivative of this? We have negative 8x plus 40. Okay, then equate this to 0. Okay, so we have negative 8x plus 40 is equal to 0. X is equal to 5. Okay, so let us substitute, okay, 5 in this equation, x by 5 in this equation. We have there y is equal to, we have negative 4 times 5 squared plus 40 times 5 is minus 10. So y is equal to, we have 90. Okay, so our critical points are, we have 5 and 90. Okay, so this is our critical point. Okay, critical point. Okay, so how are we going to test if it's maxima or minima? So let us just get the second derivative. If this is the first derivative, then y double prime is equal to negative 8. So since this is negative, so it means that this point is what? Maxima or maximum point. Okay? Next. Okay, so how are we going to use that in business? Application of maxima and minima in business. Okay, so the profit function of a manufacturer is given as P is equal to negative 0.1x squared plus 5x minus 40. Okay, where P represents the profit, while X is the number of units to sell. So let us find the maximum profit. Okay, So again, we just need to find the first derivative. Okay, so we have here P is equal to negative 0.1x squared plus 5x minus 4t. Okay, so P prime is equal to negative 0.2x plus 5. Okay, equate this again to 0. We have there negative 0.2x plus 5 equals 0. X is equal to 22.5. Okay, so this is our maximum profit. Okay, so next, let us try this example. This is our last example. The selling price of a particular article is 200 per unit. Okay, so it has been decided to reduce the price by 1%. Okay, of the volume of sale. Variable cost per unit is 150 and the fixed cost is 10,000. Okay, so write the TRTC and profit function and then find the BEP quantity and find the maximum profit. Okay, so for this one, we have the TR is, okay, again, we have the selling price is equal to, the original selling price is 200. That was reduced by 1% of the volume of sale. That's 0.01x. Okay, so for the TR, okay, TR is equal to 200 minus 0.01x times x, which is 200x minus 0.01x squared. Okay, what about the TC? So for the TC, okay, TC is equal to, we have 10,000, the fixed cost, plus our variable cost is 150x. Okay, so for our profit, that is equal to, we have 200x minus 0.01x squared minus, okay, we have our TC of, okay, 10,000 plus 150x. Okay, so let us simplify. P is equal to, we have negative 0.01x squared, okay, plus 50x minus 10,000. Okay, so for our BEP quantity, if this is our profit function, okay, so again, let us use our calculator, okay, to find our 2x values. We have there x1 is equal to, we have 208.71 and x2 is equal to 4,791.29. Okay, so what about our maximum profit? Okay, so this one, let us compute for the first derivative, okay, or P prime. Okay, so we have there P prime is equal to, okay, negative 0.02 x plus 50. Okay, so let us equate this to 0. Negative 0.02x plus 50 equals 0. X is equal to, we have 2,500. Okay, so that's all for our break-even analysis. Okay, thank you so much and God bless.